Welcome to the wonderful world of equations. This is my favorite thing in math, and hopefully it will be yours as well. All right, in order to solve equations, I have four things here listed. This applies to all equations that you're solving. So I want you to write this down and make sure that you really understand this. First of all, the goal is always to get the variable by itself. So if you have x, you have y, whatever it is, you want it to be x equals something or y equals something. That's always the goal. So you want all the other stuff that's with it to go away. To solve equations, you perform opposite operations. For example, the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of exponents is roots, and so on. The third thing, you could do anything you want to an equation as long as you do it on both sides. And here, let me give you this as an example here. I have a little statement here that's true. Okay, if I decide I'm going to add 4 to this side, I end up with a statement that's no longer true. But if I do it to both sides, now it's true. Okay, that's the idea, the same idea with solving equations. That whatever you do to one side, you do it to the other side, and it's still a true statement. You didn't change anything. It's not going to, proportionally, we're okay. So the last thing then is you can verify if your answer is correct by performing a check step. That's beautiful. So that means when you turn in a test, you know whether or not you're right because of this check step. So let's go on to a sample. Here I have x plus 5 equals 13. You need to know what x is. Now I know most of you are looking at this like, oh, come on, Mr. Jones, that's so easy. I understand it's easy. It's to prove a point. You should be able to look at this and say, yes, I know that x is 8. Great, you're a genius. But the point is, how do we solve this? First of all, I want you to know that I insist on neatness. When it comes to equations, I do not accept sloppy work. You have to not only be neat, but you have to show me the work properly or I'll make you redo it all. So, what I said before, you want to get the variable by itself. So right now I have x and I have 5 with it. I want to get rid of that 5. That 5 is a constant term. When you're solving addition and subtraction terms, or addition and subtraction one-step equations, you want to get rid of the constant term. So that's our goal here. We're going to get rid of the constant. So when you look at it, I have a positive 5. How do I get rid of a positive 5? I do the opposite. A negative 5. I remember I have to do it on both sides. I'm going to erase this little box here because that's not necessary. I just wanted to show it to you. Now, a positive 5 and a negative 5 become 0, meaning the only thing left on the left-hand side is x. On the right, then, I have a positive 13 and a negative 5 gives me 8. So I have my solution, x equals 8. For the check step, you actually have to write the word check, so get used to it. Then what you want to do is use the original equation given to you and substitute whatever you say x is into that equation. So I'm saying x is 8, so I'm going to put it in here. 8 plus 5 should be equal to 13. Now, a lot of students will put that in like that and stop. That's not finishing your check. You will lose points with me for that. You would do 8 plus 5 gets 13 equals 13. You go all the way down to the end there, and that shows that, yes, you end up with a true statement, which means that the solution actually is 8. So in other words, if whatever you say your solution is, if you put it into the original equation for x, you should end up with a true statement. And that's what we have, is a true statement. So in other words, our solution is correct. Let's try some more samples. I have y minus 7 is equal to 45. So I'm going to do the opposite of a negative 7, which is a positive 7. And I do it to both sides. On the left, I have just y. And on the right, I have a positive 45 and a positive 7 gives me 52. And I'll check it. And I have 52 minus 7 should be equal to 45, and it is. Another common mistake that I see students make is they put the number in for the check step, and then they just assume that it's actually correct without doing the math. Make sure you do the math, because this is telling you whether or not you're correct. So I want you to pause the video and try the next 3. Be careful though on this one. It's a little tricky, okay? So try those, please. Alright, first, this one here, I have a positive 3. I want to get rid of it by doing a negative 3. Leaving just f on the left and on the right, 27. For my check step, I'm going to take 27. I have 3 plus 27 should be equal to 30, and it is. 30 equals 30. We're good. This one is tricky because you have the double negatives. The first thing you should do is this before you try and get rid of anything. Then you want to get rid of a positive 9 by doing a negative 9 or subtracting 9 on both sides, leaving z is equal to negative 9. For my check step, I have negative 9 minus a negative 9 should be equal to 0. This is negative 9 plus 9 equals 0, and 0 equals 0, and it works. Notice there was one more step in this check step, and that's because of that double negative up there. For this last one then, the opposite of a negative 12 is a positive 12. A negative 12 and a positive 12 is 0, leaving just c. And on the right, positive 24 and positive 12 gives me 36. For my check step, negative 12 plus 36 should be equal to 24. Signs are different, so I subtract, and it is. I am good. Pretty cool, huh? And it only gets much more interesting from here. Make sure your work is neat. Make sure you show your work the way I showed my work right here, or you will
Step equation word problems. First, what I have here is a verbal phrase. It's the sum of 6 and a number. That's not an equation, it's a verbal phrase, but you need to be able to transform this into a number sentence. So how would we do that? Well, you have to identify the parts. First of all, this is key, sum, and then a number is a key part, and then 6. So we're identifying it, saying, well, what is it? A sum means addition. 6 is obviously a number, the number 6. And then when you say a number, that's telling you the variable. So if you were to write this, as x plus 6. That is the sum of a number, x, and 6. I'm going to give you a sheet later. I'm going to give you this one. That's going to show you how to, or what some of these things mean in a sentence. Okay? Now, the difference between a verbal phrase and an equation will have this, is 10. Is means equals. So this would be equals 10. And you could also have the word equal in there. Okay? Now, one thing I want to point out to you, because this is something that messes up students a lot, are these two things. 3 less than a number versus 3 less a number. Pause the video and see if you can find out what these would be. Okay, the first one, 3 less than a number, means that you have the number and you're taking 3 away from it. Versus 3 less a number means 3 and you're taking a number away from the 3. Two completely different things. It's really important subtraction that you get it right. All right, let's try a word problem, shall we? Jennifer and her brother have 7 tacos. Yum, yum! Her brother eats 4. Write and solve an equation to find how many tacos Jennifer eats. Now, a lot of you can look at this and say, all right, this is 7 minus 4. Great, she had 3 tacos. Great, but how do you figure that out? That is really the key, okay? So what you're going to do is you have to look for the key information in the problem. First, they have a total of 7 tacos. What we're looking for is how many tacos Jennifer eats. Her brother eats 4. This is the key information. I always go into my word problem and highlight it or circle it or do whatever I need to do. Then what I'm going to show you is a let statement. You have let equal This is to help you identify the variable and how to use it in an equation. So you could say let x or n or y or whatever you want to call your variable equal whatever it is that you're solving. And if you go to the last sentence of a word problem, it's usually what you're solving. And what is it? How many tacos Jennifer eats? How many tacos Jennifer eats? The reason for this let statement is to help you identify what you're actually solving for so that you can set up your problem. Okay? So, when you were doing this, you would say x, the number of tacos that Jennifer eats, plus the tacos that her brother ate would be equal to the total amount of tacos that they had. So x plus 4 equals 7. If you were to solve it then, minus 4, x is equal to 3 tacos. And again, when you would answer this word problem, then you would look up at your let statement and say, oh, I would answer it by saying Jennifer ate 3 tacos. Anytime you answer a word problem, always look at your answer and see if it makes sense. If you set this up as an x minus 4 equals 7, then you would end up with more tacos than you actually had to begin with. So you got to be careful. Always look back at the problem and say, does my answer make sense? That is all. Goodbye, my friends.